In this video we'll be making the final part in this little project, the shaft that holds all these parts we've been machining together. This is all lathe work. It's fairly basic lathe work, but there's a good assortment of different practices that we'll need to accomplish to make this part. We have several different diameters, 3 different diameters. One of them is a diameter turned to a shoulder. 2 of these diameters have tolerances on them. In this case, minus tolerances. They're nominal dimension plus nothing minus 5/1000. That's so they'll fit inside the holes we drilled in all those plates. We have an angle here, a 45-degree angle on under the head here. We'll be doing some facing, and we'll be doing some center drilling and a little bit of turning. Well, not between centers, but we're going to use a center to support the end of this part when we turn the diameters. You'll see, well, here we have a note instead of a dimension on the length of this second diameter, and the reason I did that is when you buy sheet stock like we use to make these plates, it never comes in right at nominal size. It's always a little bit big or a little bit small. So rather than, and when you got 10 of these all stacked up, that little variation adds up. You end up with 10 times that variation. So we can't assume these are all going to be 1/8 inch thick. So I just put a note on there, so when you make yours you'll have to measure them. And we have 10 pieces here, 1/8 inch thick. That should have been 1 1/4 inch, and we end up, they actually measure 1.213. Okay, so look at the note down here. It says this dimension is equal to the thickness of 10 metal plates. 1.213 plus 80 thousandths is 1.293. So let's just make a note of that. 1.293. We'll need that when we lay out that second diameter. Another note I see here is anneal this area, pointing to the small diameter on the end. The reason for that is, if we pull out our assembly drawing again here, you see all these plates stack up, and then the shaft goes through the middle of them. And this small diameter extends through the bottom plate and out past the bottom. Remember that bottom has a small countersink on the back side? Well, what we'll do is we'll flip this thing over. We'll assemble it all with a shaft, flip it over on a steel block, and then we'll hammer that part of the shaft sticking through. We'll peen it over with a hammer and rivet the whole stack together. And then we'll dress it off in the belt sander to make it look nice. So by heating the end of that shaft up with a torch, we'll take all the temper out of it, make it soft so it's much easier to hammer. So that's about it. I'm going to start out with a piece of 3/8 stock. I made it a lot longer than I need, so I can make one part on each end and have something to hold in the center. So with that, let's move over to the lathe and start making this part. So the first thing we need to do to make these parts is to face the ends of the stock off. Facing is always the first operation on the lathe. I'm going to use a collet to hold the stock. And I'm going to use, if you've watched my video on grinding turning tools, you remember I mentioned that you can grind these with no side cutting edge angle on them, with 0 side cutting edge angle. That's what this is. It's a turning tool, but this tool works well for turning to a shoulder, which is what we're going to be doing here. So that's why I decided to use this type of tool. So we can face this off using this tool, and we can go ahead and turn our shoulder. And if we angle the tool around, we may not, we probably won't be able to use it for the angle at the head of the shaft, but we'll probably use something different for that. But we can certainly face the ends of the shaft off with this. So let's go ahead and get started on that. Turn on my power here. For parts this small, you want to really run the RPM up. You can't go too fast with aluminum on a small part like this, so crank right up there. I'm turning about 2,000 RPM right here. So let's just get my tool centered vertically on the part. Okay, center line of the part. So let's just take a little bit off. That's one end. Flip it around. We're making two parts, so we have to work from each end of the shaft. I like to, if I'm taking a lot of stock off, I like to cut feeding in, and for a finished cut, just cut feeding out. Leaves a nice smooth finish. Alright, so we have our ends of our part faced off. Next thing we need to do is put a small center hole in it, because we're going to be using a center to support the end of the shaft when we turn the diameters, because this is such a small diameter. It's a long, slender shaft. 7/32 in diameter and about 1 5/8 long, so it needs some support on the end. So I got a #1 center drill here, just enough to support the end of it. When you're center drilling, you want to be careful not to go too deep. You should go in about 2/3 of the way up the cone section of the center drill. If you go too far, you end up with a straight-sided, almost like a counterbore in the end of the part, and that's not going to provide much support on your center. If you go in about 2/3 of the way, you've got a nice 60-degree cone-shaped hole in the end of the part that the center will fit in nicely. So let's go ahead and center drill the end of the part. Go about 2/3 of the way in, about like that, just enough to support it. Go ahead and do the other end. If you're doing steel or you're doing a larger center drill, a little bit of cutting oil might help. A little WD-40, or a little, for steel you might want to use like a heavier cutting oil. WD-40 works great on aluminum. So now that we have the ends of our piece of stock faced off and center drilled, it's time to move on to the next operation. We're going to be turning a shoulder, turning a diameter to a shoulder. This part has a 0.156 diameter end on it, plus nothing, minus 5 thousandths. 280 thousandths long. So let's go ahead and turn that shoulder. Got the collet set up. We'll just put the part in it. Let me zoom in here a little bit so you can see what's going on. Alright, if you have a carriage stop, you need to get your carriage stop out. This lathe has a dial stop on it. It was just a 1-inch travel indicator. It's pretty handy. It works a lot easier, a lot nicer than a hard stop. I'll show you how it works here in a second. First thing we need to do with any stop is pick up the end of the shaft. So if you have a hard stop, you probably want to get close to the shaft, run your carriage stop up against the saddle and lock it down. Zero the dial out so you have someplace to start. Then just feed the tool bit in with your compound rest until it touches the end of the part, like that. Okay. So now you're zeroed out on your carriage stop. Let me show you the stop on this lathe. Okay, all it is a 1-inch indicator on a sliding bar. You just slide it up against the side of the apron or the saddle, lock it down, and zero it out. Okay, so that's the end of the part. And we want to move over that 280 thousandths, we just crank it over 280 thousandths, like that. Do basically the same thing with the micrometer carriage stop, except you have to run up against the end of the part and then you have to back your carriage off. So let's see here, let's get repositioned. And first thing we need to do is zero the dial out on a cross slide. So scratch the surface and set your dial to 0. Take a little cut. And let's see where we are. We're looking for 100, what did I say, 156 thousandths plus nothing, minus 5, so we're shooting for about 154 diameter. And right now we are at 365. I'm not going to try and do math in my head, it's too late for that, so let's go 365, 0.154 minus, got 211 thousandths to go on the diameter. Alright, let's go ahead and, what I like to do when I turn to a shoulder is I like to go over and mark the shoulder before I start. And go over 280 thousandths and just give it a little mark. That kind of reminds me when I'm getting close to the shoulder. Now I'll come back and I'll take my 211 thousandths off. I'll just go just 200. Stop a little bit short, 5 thousandths or so. And we'll go in the full 211. Take finish cut. Stop 280 thousandths in. Face out. Okay, got a nice shoulder there now. Hopefully it'll be 154 thousandths in diameter. Let's find out. Look at that, 154. Alright, that's one end. So now let's flip it around and do the other end. Remember, we're making two parts at once here, so while everything's all set, we'll do it once more. Touch off on the end of the part. Zero out the carriage stop. Move in 280 thousandths. Mark the end of the shoulder. Now we're all set on our diameter here, so I'm gonna go for it. Stop at 275. And take finish cut. Stop at 280. Alright, that takes care of the shoulders. So now that we have the small diameter turned on each end of the part, let's move up and do this larger diameter, the one with the angle, the 45-degree angle at the under the head. We already know the length of it because we calculated it from the thickness of the 10 middle plates and then added the 80 thousandths to it. So we have that dimension in hand. We're going to have to change tool bits because of that 45-degree angle. Instead of using one with the straight cutting edge angle, I'm going to use this one that I made in that grinding video a while back that has a 15-degree angle on it. And the reason I'm going to do that is I'm going to set the tool cutting edge angle up to 45 degrees to the center of the part, and then just use that to cut that angle. And to do that, we got to rock the tool bit way over like this, so I need clearance around the spindle nose of the lathe. If it's straight along this side, that means I got to go that much farther, and I'm going to run out of room around the nose. So we'll use this tool bit. I think it'll work out pretty well. think I'm going to make sure this part's out far enough. I'm going to stick it out about 2.5 inches. That should provide adequate clearance around this end. And we swing the tool around. Let's get the end supported with the center. Like that. I'm just going to use the square head off my combination square, off a small combination square, to set this tool on 45. Let's see here. It's not a real critical angle, that's why we're doing it this way. There are other ways to machine an angle like this. This is the simplest. Other ways are you could set your compound on 45 and then just use the point of the tool to generate that angle. That would give you a little more precise angle, but it's not really necessary in this case, so we're going to do it the easy way. Let's see. Okay, so now we need to know how far up to turn that shaft. Our dimension's 1.293, so let's just put a pencil mark 1.293 up. I'm going to call it 1.3, okay? It's better that it's a little long than a little short. You can always shorten that up. Alright, so let's just turn to that pencil line. Right there. Now I got to recenter my tool vertically because this is a 3/8 tool, or a 5/16 instead of a 3/8. So I got to raise it up a little bit. Always make sure the point of your tool is on the center of the part. Alright, so now let's take same as we do whenever we turn a diameter. First thing we got to do is take a skin cut on the diameter and set our cross slide dial to 0. So let's do that. Okay, there's 0. Let's take a cut. Since going all the way across, it just wastes time. All we need is enough to measure. Get our micrometer on. So let's see where we're at here. Looks like about 0.372. It's too late to be doing math in my head, so I'm going to use my calculator. 0.372, and their final diameter. Look on the print here, final diameter is 219 plus nothing minus 5, so it's 219 minus 2, about 217 is about the center of the tolerance, so let's shoot for 217. So 372 minus 217 is 155 thousandths. That's how far we have to go. Okay, what I like to do, rather than leave it on 0 and crank in 155, and since I'm doing more than one part, I'm going to have to do it a couple times, so I have to remember that number each time. What I like to do is just run it back to 0 and then reset my dial at the amount I want to take off. Then I end up on 0 when the part's finished. Makes more sense. So I'm going to do that. $155 is right there. Okay. I'm going to take off about 20 thousandths. Sure, center drill is tight enough here. You can see we're turning that 45-degree angle on there. Stop the power feed a little bit before the pencil line. These chips off of here. Never grab these chips when the spindle's running because they do get sharp, especially steel. Aluminum's not too bad, but steel will really bite you. Alright, so now just kind of sneak up to that line. Oops. Okay, that line, I'm thinking the wrong. You gotta line the point of our tool up with that line, not the top. So let's eyeball the point of the tool up with that line. And I'm going to set my carriage stop so I know where that is. Let's zero that in. Alright, now I can go to my carriage, to my dial on the carriage stop reads 0. Then I know where to stop. So let's do that. Right there. Okay, so now take another cut on here and just check my dimension. I'll go down 10 thousandths before finish the final diameter. Take a cut and then I'll check it. If it looks good, I'll take it down to size. So we should be 227 here. 10 over the finished diameter. And we're at 227.5. That's close enough. Start over here and we'll go in the rest of the way. So my carriage stop reads 0. Right there. Alright, I'm going to double check this diameter. It should be 217. Alright, it's 218. I'm going to take another 1,000 off. I'd rather have it a little looser than tighter. Alright, that's one end. Now let's flip it end for end and do the other end. Same way. Dials are all set now, so we don't have to do any checking. Just use our settings. The cross slide dial set. We'll have to reset the dial on the carriage stop. Said 1.3, I believe it was. Alright, that's pretty close. Within 5 thousandths. Alright, so now go down and take a cut within 10 thousandths. There'll be one roughing and one finishing cut. Looks like I need a chip breaker on my tool here. Aluminum's difficult to make the chip break. That's why you always see these long stringy chips. Steel's a lot easier to control the chip. Alright, and a finish cut. Alright, that should do it. Now, one thing that's left is to part these guys off, and then we can start assembling. So let's Put our parting tool in. And do a little parting. I'll show you it's not as scary as everybody thinks it is. Alright, parting tool. First thing you gotta do is make sure it's on center vertically. So we're just gonna line it up with the end of our part here, kind of sight along it. Get it on center vertically. Next thing we're gonna need to do is make sure it's square. It's perpendicular to the part. I'm just gonna run it up against the end of the spindle here. Nice square surface. And I'll just adjust the tool hole or the tool post until it's perfectly square. That's the biggest thing about parting. If that tool's not square, it's going to bind up in your slot and cause you a lot of grief. So parting, you also want to make sure everything's up tight, no overhang on the tool and no overhang on the part. Alright, looking at the print, the head of this thing is parted off 85 thousandths from the end of the middle diameter. So let's just measure over. This is not critical because this is going to be dressed off when the parts are all assembled. This is going to be cleaned off. But you know what? We forgot a diameter. Let's stop here. Almost screwed up. We forgot to turn this outer diameter here. It's supposed to be 5/16, 0.31. And the stock is 375, so we need to take a cut on that. So I'm going to do that right now. Touch it, set my dial to 0. Take a cut. You do that every time. Every time you turn a diameter, you go through that procedure. You get pretty good at it after a while. Now we can measure it and see how much more we have to go. We're at 367 thousandths. We want 310, so we've got to go 57 thousandths farther. It sounds like one cut to me. Alright, do the same thing on the other end. $57 thousandths. Now, put that parting tool in and cut these babies off. Now that 85 thousandths will look a little more realistic. That's what caught my attention before. That didn't look right. Somewhere about here. Like I said, it's not critical because when we assemble these things, both ends of this shaft will be belt sanded flush to the plates. A little WD-40. WD-40 works great for aluminum, and just part it off. Same thing on the other end. WD-40. This is a small part. Bigger parts are tougher. There's no way the parting tool is going to cause me grief on a part this small, but they can get kind of touchy on larger parts. But like I say, square everything up, make sure it's on center, use oil. And if you're doing steel, use a heavy cutting oil and sulfur-based threading oil. Aluminum, WD-40 is fine. And make everything as rigid as possible. Okay, so we got a couple shafts. That's the last of the part. Now we'll move over to the bench and put these things together. So I don't know about you, but I'm pretty excited to get these things together and see how all these parts work out that we made. So let's get going on the assembly. Okay, the first thing we need to do is anneal the end of these shafts. Remember on the print it said they need to be annealed. So all we do is take our propane torch, get them nice and hot on the end. We need to get up around 900 to 1,000 degrees, somewhere in there. That's about the limit for this propane torch. That ought to be good for that one. Alright, you want to go on the bench? You can go on the bench. Heat this one up. Get all that temper out of the end of it. We can do turn it into a rivet. Alright. Now we have to wait. Can't quench it. If we quench it in water, it'll bring some of the hardness back, so you got to let it air cool. So let's take a break. I'll be right back. Okay, finished parts. Let's put these babies together. Now let's see. We need a top plate. And middle plates. Alright, should have a little bit of the shaft sticking through, and that's good. And the bottom plate with the countersink down. Alright, now let's lay the whole stack on a piece of steel. I'll just use this parallel. And flatten out the shaft where it sticks through. Kind of keep checking the parts, make sure they're not tightening up on you. Alright, I think that's pretty good. Maybe a couple more wraps here. Alright, here's one. Let's do the other one. Takes longer to put them together than it did to make them. There we go. Alright, got a little bit sticking through, that's a good thing. Countersink to the bottom. Oops, that one's not in all the way. Somehow it got out. Alright, I'm going to have to work on that one a little bit. We got one ready to go here. Let's move over to the belt sander and clean it up. Okay, you can see what they look like here. We got a little bit sticking out on the top. We can dress off on the sander and a little bit on the bottom. A couple swipes and it'll be done. There we go. One complete set of stack blocks ready to get put to work on your milling machine. That's about all there is to it. Hope you had fun building the project.